talk about resistors, and we are going to begin with the resistors in series. And in this illustration, we have 3 resistors connected in series like this, whereby for these resistors to be in series, they must be connected end to end. In this case, we have resistor R1, resistor R2, and resistor R3. For today now, we want us now to know how to get the total resistance in this circuit here. The current I is the same throughout all the parts of this circuit here. For resistors in series, the current from the source will be the same current flowing through R1, will be the same current flowing through R2, and will be the same current flowing through R3. And again, V, the source voltage here, is supposed to be equal to the voltage drop across resistor R1 plus the voltage drop across resistor R2 plus the voltage drop across resistor R3. Now I'm going to write V is equals to V1 plus V2 plus V3, and that is according to the Kirchhoff's voltage law. Let us call this equation Roman 1. And again, from Ohm's law, voltage is given as current times resistance. Let us call this equation Roman 2. Now, how do we get now this V1? V1 is the voltage drop across resistor R1. How are we going to get it? You know that voltage is current times resistance. Now we are going to multiply the current here times the resistance here, which is R1. Now I'm going to write I R1. That is V1. What about V2? The V2 here now will be equal to the current here times the resistance here, which is R2. And the last voltage drop here, which is V3, is given as the current flowing through this resistance R3 here times the resistance here, which is R3. Let us call this equation 5. Now, we are going now to substitute all these equations using equation 1 and equation 2. Because you can see from this equation here, V is equals to V1 plus V2 plus V3. And the source voltage, which is V, is given as current times resistance, which is actually supposed to be the source current times the circuit resistance, or the total resistance. In this case now, I'm going to write, instead of V, I'm going to write IR. IR is equals to, for V1, we have IR1, and for V2, we have IR2, and for V3, we have IR3. So we have IR1 plus IR2 plus IR3. And again now we are going now to substitute to factor out the common factor here. And you can see we have I appearing on this side and also on the other side. Now I into R is equals to I, and then we remain with R1 plus R2 plus this R3 here. I is appearing on the right hand side and on the left hand side. So we are going to divide both sides by I so that the I cancels out. So that now we remain with R is equals to R1 plus R2 plus R3. This is now the circuit resistance, or the total resistance, which is given as RT is equals to R1 plus R2 plus R3 plus, you keep on adding up to the last resistance. That's our final expression.